Yeah, you guys able to see now?
Yes, sir.
Yeah, so center of mass formula, I told you this, right? And so on like this. So, okay, so given the center of mass of each particle, then we can calculate what is the center of mass of the whole system. So if I differentiate this whole thing, what I will get? Velocity of center of mass. That is given by m1 v1 plus m2 v2 plus and so on divided by m1 plus m2 plus and so on. Okay. Similarly, if I differentiate it further, so the acceleration of the center of mass is m1 a1 plus m2 a2 plus so on divided by, all these are vectors, okay, m1 plus m2 plus and so on. Please note it down, students. Done?
Yes, sir.
Okay, so for example, let us take one example of a pulley block system M1 and M2. Okay, so I want to calculate what is the acceleration of center of mass of this system. So for that, what you have to do is first write down the accelerations. This will be A1 and this will be A2, and we know that, you know, with which acceleration this block moves up, same acceleration this comes down. So we know all those two are equal in magnitude, A and A. Okay, so what will be the acceleration of center of mass? It is m1 a1 vector plus m2 a2 vector divided by m1 plus m2. So acceleration of center of mass is equal to m1 times, what is a1? That is a in upward direction. So I'll take it as plus m2 times a2 is in downward direction. So minus a divided by m1 plus m2. So from here I can say m1 minus m2 over m1 plus m2 times a. But what is this a? That we learnt in Newton's laws of motion. How to calculate that? So to calculate acceleration, simply we do that supporting force is m2g minus opposing force is m1g divided by total mass. This is my acceleration. So I will put it here. So it will be m1 minus m2 whole square divided by m1 plus m2 whole square times g, but you can see there is one minus sign, okay, because that is m2 minus m1. Here it was m1 minus m2. So this is your acceleration of center of mass. Okay, any doubt here? So you can feel that, well, if this is the mass, okay, and this is the heavier mass, so the center of mass of these two will be somewhere line joining here, right? Since the heavier mass is going down, the acceleration of center of mass also goes down. That's why the symbol minus is coming here. Okay, this question understood?
Yes, sir.
Okay, take the screenshot or note it down. I will go for next page. So let us calculate some simple geometries. Okay. So let us say there is a rod of mass m, length L, mass m, length L. We want to calculate what is the center of mass. So in question they don't give you where is the origin and all, so you have to consider it. Okay. So in such questions, what you have to do is you consider this as origin. Any common point you consider. Then you know that center of mass of this rod will be at the center. So you can write its coordinate as mass m, center is L by 2. That will be the position, right? So sorry. So mass is m only, but the position can be written as x position L by 2, y position 0. Can you guys tell me what will be the coordinates for this center of mass of rod? Anybody?
0, comma L by 2.
0, comma L by 2. Well, so directly you can say that the x center of mass is m1 x1 plus m2 x2 divided by m1 plus m2. So from here, this is your x1 y1, this is your x2 y2. So just put the values, you'll get as ml by 2 plus m into 0 divided by 2m. So that is m got cancelled out. So you got L over 4, correct? Similarly, y center of mass, you will get L by 4. Finally, the center of mass is at L by 4 I cap plus L by 4 j cap. So you can say that the coordinates of the center of mass is L by 4 comma L by 4. Okay. Any doubt, guys?
No, sir.
So always remember in that, if you don't want to calculate and just guess the answer, what you can do is you have to join the center of masses. So always the center of mass exists on the line joining. So any point on this line it will be. Some people say that okay, this is L by 2, this is L by 2, the center of mass will be at L by 2. People say this, the center of mass is here. Is it on this line? No, right? So this is wrong. Always it will be on the line joining the center of mass. What we did, we replaced this rod with a single point where its center of mass is. Again, we replace this rod with a single point where its center of mass is. Then we'll join it. So wherever it joins, at the center, the center of mass will be. Okay? Any doubt? Any doubt, guys?
No, sir.
Hello? Okay, take the screenshot and we'll proceed. See, to show this example, I can take this example. So let us take this example. Now I have 4 rods. So what is the procedure? You m L by 2, right? Mass all are m. Just write the coordinates. This will also be at L by 2, right? This will also be at L by 2. This will also be at L by 2. So you join all the center of masses. Where they are intersecting, that is your center of mass. Correct? This is your center of mass. So one example I will give you, you try it out. Try center of mass of this. Try it out. First, geometrically draw the lines and see, and then you calculate. Okay, consider this as origin. Tell me what is this is x-axis, y-axis. Calculate the center of mass. All are of mass m, length L, mass m, length L, mass m, length. Hello, Shrita,
Yes, sir.
done?
No, sir, not yet.
Xavier,
Yes, sir.
what is the answer?
It's still doing.
Write all x and y coordinates of all three rods, then calculate for x, then calculate for y. That's it.
Uh, So I missed the previous two classes, so it's a little new for me.
You miss again.
No, sir, I missed the previous two classes, because I had my computer exam today.
How was your exam?
It was easy, sir. Like they asked tricky questions, but it was easy overall.
Okay. See, guys, tell me what is the coordinate of this point. Tell me, Xavier, what is the coordinate of this center of mass? Tell me.
So it is the thing x-axis, no?
So L by 2, 0,
By
right?
two. Yes,
What
sir.
about this? Tell me quickly, what is this?
This will be 0 by m by 2.
And
And
this
this will be same.
x.
This will be in minus, sir.
Why minus? Is it in negative y axis or negative x axis? Are you class 4 student or what? This length, x axis length is how much? L. Y in y
L.
how much? L by 2. This much you guys are not able to do. Now calculate x center of mass. Multiply all masses with their corresponding x. M into L by 2 plus M into L plus M into 0 divided by 3M. Check. What will be the x? M into L by 2, M into L, M into 0. Correct. So from here, 3 by 2 ml, right? Divided by 3m. So 3 got cancelled out, mm got cancelled out, L by 2. So here we are getting x. What is y? Y center of mass, anybody? Y center of mass, anybody? m into, see, m into first one is 0, y coordinate, plus second m into L by 2, plus third m into L by 2, divided by 3m. So the upper one will be ml by 2 plus ml by 2 will be ml. So ml by 3m, so it is L by 3. So it will be somewhere here, okay, L by 2 comma L by 3. Okay, understood everyone?
Yes, sir.
Yes, sir.
Even geometrically I told you, right, to check how you can do that. First you replace this rod with one single point. You replace one single point. You replace this rod with one single point. They are on same axis, and you replace this with a single point. Replace. Take any two. Take any two first. I will take these two. Where will be their center of mass? In the middle. Correct, right? Now these two are gone. Now join these. Where it will be? In the middle. Somewhere. Because this will be of 2m mass, right? This is of mass m, so it will be just nearer to this. Somewhere here you can guess. It will be, of course, less than L by 2. That's why the answer is coming L by 3. By doing this, you can save your time. That's why I'm teaching this. Otherwise, keep on doing. That also you are not able to do. Okay, now coming to the main picture. So you guys, I told you to remember those center of mass formulas for different shapes, right? Guys, remembered? Shayuta?
No, sir.
Why? Didn't you eat today? You had your lunch?
Yes, sir.
Shayuta? Yeah, then why not memorized? Justify me, don't be quiet here.
Sir, I was out of my house today, so I wasn't able to do anything today.
Samhita? Samhita, are you there?
Yes, sir.
Why did you not do?
Sir, I forgot about it, sir.
Excuse me, sir.
What?
Sir,
So please guys, remember, memorize those, okay? Center of mass of different shapes. Okay?
excuse me, sir.
Yeah, Xavier, tell me.
Sir, someone's asked for the meeting link in the group, sir, to join
Someone
the
is
meeting. Someone's asked the meeting link to join the class.
who is asking?
Uh, it's in the group, sir, some Krishna Mahesh.
Just Krishna Mahesh. One second. Okay, so that's not our job. So the team will take care of that. Okay. So all of you remember, okay, I will give you shapes also if you want. You have to memorize the center of mass of a semicircle. Okay, what is it, the value? I will ask tomorrow, all of you. And a cone, hollow cone, solid cone, okay, and a sphere, half sphere, okay, half hollow sphere, half solid sphere. All those you have to memorize. No compromise. Not giving you any assessment, any homework. Small homework I'm giving you and you're not doing. Okay, let's come to the topic. So we said that velocity of center of mass is given by m1 v1 plus m2 v2 plus m3 v3 and so on, right? Divided by total mass m1 plus m2 plus m3 plus dot dot dot. So students, if I say that there is no external force, the F external is 0. What does that mean? Acceleration is 0, right? Correct? Hello?
Yes, sir.
If acceleration is 0 means velocity is constant, correct?
Yes, sir.
That means this VCOM is constant, correct? That means M1 V1 plus M2 V2 plus and so on should be constant. This is called conservation of linear momentum. So if someone asks you what is the condition for conservation of a linear momentum of a system, then you should say that there should not be any external force. Okay, guys? This means what? There is no change in momentum. That means P final minus P initial equal to 0, which is nothing but P final is equal to P initial.
Done, sir.
Done? Very good. Okay, so you understood what is conservation of linear momentum, right? Now, we'll talk about little bit about spring block systems. Okay, so let us say I will give a velocity v1 to this and v2 to this. Okay, so and this mass is m1, m2, this is m1. Okay, so see, interesting, very interesting this is. Now, what happens is if let's say v1 is greater than v2. So how this system looks like? It looks like the, you know, the both the masses are, compressing and stretching and they are also moving forward. Okay. So, after sometimes if this might compress and then expand and it will also move forward. Are you able to imagine this situation? What happens if we give the velocities in these directions? Xavier? Xavier,
Yes, sir.
you are able to imagine this situation?
So it will come back, right? Like,
Yeah, so it will come back, but still it is moving, right? See,
yes, sir.
what this V2 will try, it will try to take it back, right? But this
Yes,
V1 will
sir.
try to pull it back. So, but still they are moving. The moment it pulls it back, this goes little bit like this again, because V2 is fixed. No, V2 is fixed. The moment it compresses, then again it goes back. So the whole system moves like this, like this, like this, like this, like this infinitely. Okay, because there is nothing which can stop this. Okay, no friction, nothing. Understood, everyone?
Yes.
Yeah. But one interesting thing here is there any external force on this system? Is there any external force on this system? Any force I am applying, simply use your common sense.
Yes, sir.
What is the external force here?
So when the object is moving in the V2 direction, an external force is applied. And also
Here,
an external force is
yeah.
applied to bring the object back.
See, this here you are saying that this is the external force, right? Okay. The same amount of force is being applied here also, no? You are understanding me? External means if you consider only M2 as your block, then this becomes external. But whole system is what? Whole system is M1 plus M2. Correct? So in on this system, is there any external force? No, right? Because the spring force which is acting is internal and the total spring force is 0. Because on M2 it acts in one direction, on M1 in another direction, and they are in same magnitude. Because F is Kx. So X is same, right? So it will be same. So the net, that is internal force. Okay? Understood? So no external force. You can say that, well, what is the initial momentum? M1 times V1, positive direction, huh? Minus M2 V2. I kept minus because a negative direction. So this should be equal to constant. This cannot change. Okay, after sometimes, let's say the V1 changes, V2 changes, something happens, but that will always be equal to this value. Okay, understood, everyone?
Yes, sir.
Yes. So, but if you sit on the center of mass of these two bodies, you will see that this object is oscillating about center of mass like this, and this object is oscillating about like this. Okay, about center of mass. The forward moving motion you won't observe. Okay. So from here, can you calculate what will be the velocity of center of mass here, guys? It will not change, right? Because there is no external force to change it. So its value will be m1 v1 minus m2 v2 divided by m1 plus m2. Correct? So take the screenshot. I'll go to next
Sir,
page.
could you explain that again?
I will explain in the next page. So see, you have m1, let's say, and you have m2. Okay. So let's say I'm giving this 1 kg, 1 kg will take. Okay, m1, m2, 1 kg. I'm giving 2 meter per second like this and 1 meter per second like this. I want to calculate what is the velocity of center of mass. So what you have to do, m1 v1, 1 into 2. They are in plus direction, minus 1 into 1. They are in minus 1 direction. So I just kept minus divided by total mass 2. So it is 1 by 2 meter per second. Okay. Now you understood? Now you understood?
Yes, sir. Yes, sir.
Understood or not?
Yes,
Yeah.
sir.
Okay.
Sir, I have another doubt regarding another chapter.
Yeah, you can ask.
So, in electric fields and charges, there's always these questions in which find the point and find the charge of the point when 2 points are present and then 1 point is brought to the null point or at equilibrium. So, how do you do those type of questions?
Yeah, I can tell you that. I think I explained you similar question in the class also. Can you read out the question?
Yes, give me 1 second.
Who is this? Samhita or Shweta?
Samhita, sir.
Hmm?
Samhita.
Okay.
One
So can
second.
you read out?
Yes, sir. Yeah. Two identical charges Q are kept at a distance of R from each other. The third charge Q is placed on a line joining the above two charges such that all three charges are in equilibrium. What is the magnitude, sign, and position on the charge Q?
Okay. So see, the line joining means it is this line, right? Two identical charges they said, correct?
Yes, sir.
So two identical charges Q are placed distance R apart and the third charge Q is brought, right?
Yes, sir.
So see, the line joining means the line is the one I shown, right? So this is the line joining, correct? So you can keep the charge here or in between or here. It depends, right? So you have to check. Okay, so if I check in the first case, these two are of same sign, right? Charges. So this charge will apply a force on this Q in the opposite direction. It will repel, right? So that will be F. Let us name 1, 2, and a 3. Okay. So force on 2 due to 1. This is. Similarly, if I see this Q, this will also apply force on this like this. So F on 2 due to 3. So you can see both are in opposite direction. So they have the capability of cancelling out each other. So you just write, let's say this distance is X, then this distance will be R minus X. Okay. Simply put the formula KQ square by R square should be equal to KQ square by R minus X whole square. Solve it, you will get R is equal to X by 2. X is equal to R by 2. Okay. This is very simple because they have given Q and Q. What if I give Q and minus Q? That you think of where I should put. You check all the positions here, here, and here. You have to see the two forces which should come in opposite direction. Okay.
Yes, sir.
Got it?
So it's basically just Q is equal to Q by 2.
Q is equal to
Q by 2 is the charge present on this one.
you put any charge in the middle. It should be positive charge. It doesn't matter what magnitude you are putting.
So
It,
they're asking what is the magnitude they're putting, sir.
what is the magnitude of charge they are
Yeah.
putting at the center? They said
Yes, sir.
they said by themselves.
Yes, sir. I'll read the question again.
Can you send me in the WhatsApp?
Yes, sir. They asked what is the magnitude, sign, and position of the charge Q.
Yeah, use. That's what I'm saying you, right? The magnitude is R by 2 and it will be like R by 2 distance from each.
Sir, they gave the magnitude as Q by 4, sir.
They gave Q by 4.
Yes, sir.
Can you send me can you send me the question?
Yes, sir. In the group. No, I can't. Okay, yes, 1 second.
In the group or into me, anywhere you can send. Please make it fast.
Yes, one sec. I sent it. It's getting sent.
Okay. Which example?
12.
12, no? Two
Yeah.
identical charges Q each are kept at a distance R from each other. A third charge small q is placed on the line joining the above two charges such that all the three charges are in equilibrium. What is the magnitude, sign and position of the charge small q? Right. So let us do it.
Yes,
See,
sir.
so you have q here and q here. They are separated by distance r, right? So if I keep it here, if I keep the charge here, both this force and this force will push it, right? So it will go to infinity. There won't be any equilibrium. So somewhere I have to put it in the middle. Okay, let's say I will keep it here. So let's say this distance is x. Okay, and this distance is r minus x, correct? And also they are saying that each charge is in equilibrium. That means this is also in equilibrium. You understood? You understand? That means that net force on each charge should be 0. So you write what will be the force on this charge. It will be k q square by r square. This is one thing. Okay. So that will be in this direction. And this small q will also push this in this direction. So then how this capital Q will be in equilibrium? It won't be in equilibrium, right? Are you understanding me?
Yes, sir.
Yes. Samita.
Yes.
So yeah, so that is not at all the situation. Like if we this is the situation, then this capital Q cannot be in equilibrium. So let me read it again. Okay, so they are saying that means for sure this Q cannot be positive, right? They are asking sign, right? So if I consider it positive, this is coming against our assumption. That's why this small q cannot be positive. Understood?
So
So
it's
if
negative plus it has to balance the other two charges out.
see, if I make it negative, what happens? If I make it minus q, so this will apply a positive force like this towards it on this capital Q, correct? And this q will apply a force away like this on this capital Q. So if I write the net force, what will it be? Kq square by r square should be equal to kq small q divided by x square. Any doubt?
No, sir.
One more equation, what you can write? Kq small q divided by x square is equal to kq small q divided by r minus x squared. Correct? So
Yes, sir.
one equation what you can write is k q small q by r minus x squared should be equal to kq square by r. So you have three equations, 1, 2, and 3. You take any two equations and solve. Okay, and you will get what is the value of q, what is its position, and what will be the sign of that q. Of course, it will be negative. Will you be able to solve it now?
So I have to equate kq by x square is equal to kq by r minus x square and solve it.
Yeah, you solve it. You'll get it. Get r and You can, and then put it in one of the equation where only small q is coming. See here, if I see, only q is coming in terms of capital Q, right? So in from first equation, can I write it as kq by r square is equal to k small q by x square, right? So once if I get the value of x, that we got how much, you calculate whatever the x you get, you put here, you get small q in terms of capital Q. Okay, sign we already know it is negative.
Sir, what if the charges are given as one charge is plus 4E and another charge is E?
What?
So what
One,
if one charge is plus 4E and other charge is E?
which charge you are saying? This is plus 4e and this is
And other
plus.
one is E, yes, sir.
Yeah, then see, then why you have to see again. See what to do in that case. You are saying, let's say this is 4q and this is q, right?
Yes.
So now, so this 4q will dominate more now. This has a capability of pulling more, right? And this has a applying less force. So if I make the distance more, okay, if I make the distance more, and if I keep somewhere here, then again it will be in equilibrium. If I keep 1 minus q, you can check that it will come more than r by 2. Okay, here it will be the equilibrium point, because 4q will pull it like this, correct? And q will pull it like this, and this will be in equilibrium. But if I check 4q, what will be the situation? This q will be pushing it like this, so minus q will be pulling it like this. So again, this will be in equilibrium. Same goes to this. Understood?
Yes, sir. So it will be 4Q into Q by R minus X is equal to Q into 4Q by R square.
Yes.
Okay.
So simple force formulas you equate, you'll get. Only here the trick will be like where you have to keep it. Okay. For that you have to do the force analysis.
Yes, sir.
Okay. All right. Anybody have any other doubt? This time is very important. You have to clear your doubts. Don't have any doubt, any other doubt, guys?
No, sir.
Okay, all right, then we covered velocity of center of mass today. So tomorrow I will cover acceleration of center of mass. Okay, then we'll see some collision, how to solve collision problems. Once we are done with that, I will be, solving some more questions to get grip on these chapters. Once we do that, we get okay. Okay, guys. Okay, all right, then we'll see you in the tomorrow's class.
Thank you, sir.
Thank you,
All
sir.
the best.
Thank you
Bye.
so